learn about this learning target that is able to use integration by parts to solve some integration problems. So we're going to first look at the equations and to try to make sense where does this particular exotic looking equation come from. So we will start with a product rule. Here we assume that u and v are both functions of x. And then if we take the derivative with respect to x, this is the result that we get from product rule. Now, after taking the product rule, what we can do is to do the reverse process, that is integrate both sides with respect to x. If we do that, then we will see, for example, on our left-hand side, this is just going to be the dx and dx. We can treat it like a fraction and they cancel out. So I have the integration of d of the product. So this means that of the reverse process of this will give me just ub, the product itself. And similarly, in the right-hand side, the dx and dx cancel, and the dx and the dx here also cancel, leaving us with this particular term in blue. So we have integration of u dv plus v du. And rearranging it, that is making this, the first term on the right-hand side, to be the subject, we will get ub minus integration of v du, with respect to du, which is this equation, as you can see, right? And the one in the box, is this one, the colorful one. So sometimes it's easier to think in terms of the colorful one, that is the one in the box, and sometimes it's easier to think in terms of the blue one. Let's see how we can use this to solve a problem. So before we do that, let us also try to see how we can memorize this. So there are two parts. The one in the box, for example, that is u and dv dx, right? And the u is what I would call the u for ugly, or the ugly part. And the ugly part is the one that I cannot integrate. And dv dx is the one that I can integrate. The integrate one, I give me this, so the process is to first identify which is the ugly part and which that is the one that I cannot integrate, that I can only differentiate, and the dv dx is the one that I can integrate. Then we keep the u, the second part blue, u in the first term in the right hand side, and then the product, the result of the integration v in the second term. And then last, we differentiate u and put it in the second term like this. And then now we can integrate. So let's start with an example. So in this example, we start with integration of ln x. Well, ln x here, you can think of it as 1 ln x. For example, if we just look at ln x like this, then you'll be wondering, well, I don't see two terms, right? I don't see two terms, only one. If I can integrate ln x directly, then I'm finished. So what we can do is that put in 1 here. So ln x is the u, and then dv dx is my 1. So this is my u is my ln x, and dv over dx is 1. Then u, I take the derivative, give me 1 over x, and dv dx, I integrate that, give me x. Then I'll just put them into this particular formula. So ub, so I will have ln x times v, which is the x, minus integration of v, that's the x, minus du dx, which is 1 over x dx. So simplifying this, I get x ln x minus the integration of dx. But the second part is just going to be simply x. Okay, it's just going to be simply x plus c. So this is the answer, and we can also check whether our answer is correct by first letting the result to be y, and then we take the derivative. You see x become x ln x become ln x plus x 1 times 1 over x using product rule, minus 1, derivative of x is 1, derivative of c is 0, and then I simplify this, and then I get ln x, which is precisely what we have at the beginning. Okay, so thank you very much